Okay, solve for x, where x is a real number, and we're getting a nested root problem. So what I'm just going to the whiteboard and sort of like walk you through it. Oh, before I do that though, I want to point out there is a link over here. I do recommend you look at the link, all right? It's somebody else doing the problem, all right? The way we explain the problem might be a little different, but not substantially so. There's other ways to solve the problem, by the way, but we want to concentrate on what I believe is the easiest way of solving the problem at this point. So I know x is a real number, and I know what the equation looks like. It's a nested root, and this goes on forever. You know what? I shouldn't have closed it out, by the way. When I say it goes on forever, this goes on forever. It's the next thing, which is a root problem again. This goes on forever too. And what's it going to be? X squared. And then what do you get over there? You get this, another square root. That goes on forever, by the way, and x cubed. Now the thing is, you're supposed to be catching on that we're going to keep writing that down, but this is going to equal the number 3. Now, I'll be honest with you, the first thing I did was I squared both sides. Then I realized I was not in a dead end, but I felt that it was going to be too complicated. Then I started thinking about maybe it's just the addition of the exponents. So if I were to look at this individually, the first thing I'd get is x to the 1/2 power. And I'm seeing that right over here. The next thing I would see is I would see x to the 2nd power, but then there's 2 square roots being done on it, which means 2 times 2. The next one I see is x cubed, but then I see 3 roots being taken, which is 2, 2, 2. Now granted, although it's not written down, I could keep writing this over here. This would be 4, and then you get 2, 2, 2, 2, all right? So, 1, 2, 2 2s, 3 2s, 4 2s, and the top numbers are just the integers, 1, 2, 3, 4, yada, yada, yada. But again, if you want to, keep writing this thing down over here. Not that it's going to be helpful, but instead of writing down 5 2s, I'll just put down 2 to the 5th power, and yada, 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 and that's going to equal to number 3. I'm going to use the rules of exponents here, and what I want to do is just add those exponents together. All right? Now to do that, I got to write it down. So really what I'm looking at, there's a sum over here. And that sum is going to be 1/2 plus 2 over 2 squared plus 3 over 2 cubed plus 4 over 2 to the 4th power plus 5 over 2 to the 5th power plus yada, yada, yada. Now, my recollection, this is a really long document. We're on page like 800 or so now. But I do remember seeing this sum before. I just can't remember directly how we did the sum before, but it looks almost like it's geometric. So what I want to do is I want to start writing down, sums that look geometric to me, but this is not geometric as it stands, by the way. And I'm just going to, say what it looks like to me, and I'll write this one down for you. And S looks like this over here. I can say it looks like 1/2 plus 1 over 2 squared plus 1 over 3 squared. And that's geometric, by the way. 1 over 4 squared. 1 over, I'm sorry, I'm making mistakes there. I'm thinking counting, but that's not what it says. I said geometric too, right? So 2 squared, 2 cubed, 3 cubed, and 4 cubed. I did it again. I'm just counting, and I realize that when I'm counting, I'm not changing the base, I'm changing the index. 2, 4, 2, 5, plus yada, 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 all right? And then I certainly have the first term, but the second term, I got to put that in. So I'm going to put, 1 over 2 squared plus 1 over 2 cubed plus 1 over 2, 4 plus 1 over 2, 5 plus yada, yada, yada. Wow, it looks complicated. Let's keep moving. I'm going to keep writing them down. I got this term, I got that term, this one, so I have to add that on now. What do you get? Plus 1 over 2 cubed plus 1 over 2, 4 plus 1 over 2, 5. I think you're getting the idea that these sums individually are doable, right? As I keep writing these things down over here, what's the next one going to be? Well, didn't get that one yet, but put that one down. It's going to be 1 over 2 to the 4 plus 1 over 2 to the 5 plus yada, 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 all right? Let's talk about what the sums look like. And, the first sum is really not that bad. I got to add them together, though. That's a problem. I should put plus signs down here. Okay, let's talk about that. So I'm going to talk about this sum first. 1/2 plus 1 over 2 squared plus 1 over 2 cubed plus yada, yada, yada. Now, thinking about it, if you thought about that, what are you going to get over here? Let's see, you're going to get 1/2, 1 minus 1/2. All right? Which is equal to what? When we thought about that, it's going to be 1/2 over 1/2, which is just 1. So this sum over here is just 1. All right? Now, if we look at the other one, a little more complicated, isn't it? And what I'm noticing is you could actually factor out 1/2 from that, and then you get the above sum from that. So what do you get? 1/2 times 1. What do you get over here? Well, now I got to factor out 1 over 2 squared, and the sum of that subsum would be now 1 again. Then when you get 1 over 2 cubed, and then you get 1 again. So I got to start to realize that these things go on forever, and I got to add that together now. Right? A couple different things adding together over here. And let me just see if I can add it together. So I'm going to say this S is actually equal to, let's see, 1 plus 1/2 plus 1 over 2 squared plus 1 over 2 cubed plus yada, yada, yada. Well, I can do that one too. All right, what's it going to be? The S here is going to be, well, the first one, 1, and then 1 minus the common ratio, which is 1/2. What do you get there? 1 over, well, 1 minus 1/2 is 1/2, and 1 divided by 1/2 is just the number 2, all right? Boy, that was a long-winded thing to get something, wasn't it? So what do we now know? I know this thing over here. Oops, sorry about that. X, the sum of the exponents is just 2, and what does that equal? 3. Now looking at that over there, again, there are some complications over here, like what can X be? I'm going to look at it, and since I'm going to say principal root, I'm just going to use the positive. All right, I want to use a negative number over there. And the thing about it, I want to use complex numbers. So what do I get over here? Wow, I just get the root of 3. So X equals root of 3, not plus or minus at this point. Now granted, I'm not saying it can't be minus root 3. I'm just looking at this thing over here, and I'm starting to see there are some complexities if it is minus root 3. I'm not saying it wouldn't sum to 3. I'm just wondering if I'm not seeing something over there. You might see someone say something about that. Certainly I would enjoy to hear someone say what they believe that the answer is to this one problem over here. But I got to commit to root 3, by the way. And we're done. Thank you so much.